Welcome to this last lesson in chapter 5, very fast I know, right? Which is on kinetic energy. So kinetic energy is also a nice concept to teach and understand, and most people find it quite easy. So kinetic energy is the energy that a mass has due to its motion. If you're moving, kinetic means movement. Like, you know, kinesthetics or something. I think that's like a type of exercise. I'm not sure, to be honest. Okay, the kinetic energy is the energy that a mass has due to its motion, and the formula for it is kinetic energy is equal to half times mass times velocity squared. Or in symbols, EK is equal to half mv squared. Now, if you watched my video before this, which was on gravitational potential energy, you might have noticed that gravitational potential energy was delta EP is equal to mg delta h, and you might be like, why is there no delta EK? It's kind of because they always assume that it was like, we always compare it to when it doesn't have any kinetic energy, so that's 0. But then in the case of gravitational potential energy, sometimes we compare it based on like different heights, like moving it from one place to another, and we don't always use like the same reference point, so that's why it's delta EP. But EK is like always like from 0, how much energy did it gain if it started with a speed of 0 and then it changed speed. Okay, you might also be thinking, why do we need to use velocity instead of speed? It's kind of the same, honestly, you get the same result, so it doesn't really matter that much. I don't know, some smart people are going to contradict me in the comments. Okay, so in general, from this formula, we can see that EK is proportional to m. So as the mass increases, the kinetic energy increases. This is quite simple because if we think about, like, let's say, not to be fat phobic or anything, if you have like a thin person and a fat person running, I feel like this is gonna offend people. Okay, no. If you have like a dog versus you have an elephant, and both of those are running at the same speed, let's say, or moving at the same speed, it's much harder to stop an elephant. The elephant is gonna have a lot more kinetic energy compared to the dog. So yeah, that might kind of be like a momentum idea, but like if you want to stop something, you have to use you have to like make the energy decrease really fast from a certain value to 0, which requires momentum, requires a larger force. So that's the idea. Like if you have a larger thing, I feel like honestly I'm over explaining. It makes sense. If you have something that's larger, it will have more kinetic energy. Secondly, kinetic energy is proportional to V squared. As V increases, kinetic energy increases. So if something is moving faster, it would have more kinetic energy. I feel like that's also obvious, so I won't explain it and complicate things. Let's say we look at an example of kinetic energy is equal to half times mass times v squared, and then we put in some values as I am doing on the right here. So a half times, like we have a 2 kilogram mass and it's moving at a speed of 10 meters per second. So we have a half times 2 times 10 squared, which 2 cancels out, giving us 10 squared, which is 100 joules. So this particular situation has 100 joules. Okay, we are gonna see why kinetic energy is equal to half mv squared, because I feel like they kind of just gave you this formula out of nowhere, right? Maybe, and then they might not have actually explained why. So we're gonna look at why. We're gonna start off with a mass that had a starting speed or initial velocity of 0 meters per second. Here, 0 meters per second. Then we're gonna accelerate it to a velocity of v meters per second. And in that time, there is a force F acting on it. It goes through a distance S, or displacement S, and it has a mass M, and the mass doesn't change because it's just a constant mass. So we know that work done is equal to the energy transferred, so we can think about how much work was done in this situation, and that would tell us how much energy is transferred. If we use the formula W is equal to F times S, see, this comes in useful. This is why you need to focus in earlier lessons in order to be able to understand things later on, because it's all related to each other. So W is equal to F times S, so F is equal to MA from chapter 3, and then we multiply that by S. Okay, this is using SUVAT. So if you remember, we have the formula V squared is equal to U squared plus 2AS, and we can apply that to this situation. In this situation, we started off with an initial velocity of 0, so basically all of this goes to 0. And then we have 2AS, so we have V squared is equal to 2AS, and we can rearrange this to get S is equal to V squared over 2A by dividing both sides by 2A. And so we can substitute in this S for this S here, which gives us M times A times V squared divided by 2A. The A's cancel on the top and bottom, giving us half mv squared. Ta-da! Okay, there are actually a few other ways to derive this half mv squared equation. So if you guys would like to suggest some other ways in the comments, because I know that you guys are very smart and good at physics, or if you are not, you will be smart and good at physics if you finish watching all of these videos, let me know down in the comments below. Okay, in terms of kinetic energy and like, I guess like why it comes in useful and that kind of thing, we have a lot of situations in which kinetic energy is converted to other forms of energy, such as like gravitational potential energy being converted to kinetic energy, etc, etc. Kinetic energy is one of the kinds of energies that come up the most often in questions, so make sure that you know the kinetic energy formula well, and it is not that hard, I feel like. You just have to be able to do the calculations. Okay, so that's it. I think I might also do some videos where we go over some more past paper examples, so subscribe for those and leave a comment if it was useful. Give this video a like, and you can go to, for one last time, www.naproudacademy.org, where you can find some past papers by topic on this chapter, as well as some mark scheme definitions, which you should go and memorize. Go and memorize them. Go! Okay, thank you so much, guys. Bye! See you in chapter 6. Sorry, I need to talk fast so like it's not boring, but then I get a bit tired. Okay, bye guys. Good luck for your exams on this topic.